Welcome to an Introduction to Astronautics and Space Systems, an online learning experience. This brief video will get you started on your adventure in space learning. Hi, my name is Dr. Jerry Sellers. I'm a partner with Teaching Science and Technology Incorporated, or TSTI. Our mission at TSTI is to provide instruction and experience to all our students so they complete this course with the knowledge and expertise to be more effective in their jobs and better prepared to tackle the challenges that lie ahead in the final frontier of space. We hope you enjoy this course and use it as a launch pad for your future space learning. Along with my fellow instructors, we'll be guiding you through the course and the online forums, answering your questions as you move through and master the material. So if you're ready, let's take off. In this introductory lesson, I'll start by going over the course objectives, then give you a big picture map of how the course is organized to meet those objectives, and the primary references we'll use. Next, I'll describe the different learning modules that you'll use throughout the course to tackle the topics. And finally, I'll describe the steps you'll need to get started learning today. The goal for a launch vehicle is to get into orbit, but first it needs to get off the launch pad and climb out of Earth's gravity well on a well-defined trajectory. This course is designed to help you climb a similar learning trajectory to help you reach your own space education goals. To that end, our first objective in the course is to build up your core space knowledge so that you can readily define and describe important terms and concepts commonly used in astronautics. This will set you up to comprehend some of the inherent capabilities, trade-offs, and limitations of space systems. From this foundation, we'll prepare you to apply these concepts to some real-world space problems, such as determining some of the fundamental orbit and system parameters that drive space mission scope and cost. These skills will enable you to analyze typical space problems, such as comparing and contrasting different technical approaches for a given mission. The ultimate objectives for this course are for you to be empowered to synthesize all of these concepts to develop the conceptual designs for a new space mission and be able to assess the technical merits of various ways of tackling them. Sound like quite a challenge? Well, don't worry. Just like a rocket going into orbit, we'll get there one stage at a time. Let's take a look at the course roadmap, which you'll see again and again throughout the course to help keep you oriented. The course is divided into 3 blocks: using space, orbits and trajectories, and space systems. The first block, using space, lays the foundation for our space launch pad by providing general background for how space missions are organized, developed, and operated, as well as some of the peskier legal and programmatic issues that must also be overcome along with the purely technical. In block 2, orbits and trajectories, we'll leave the launch pad behind as we climb into space. The first thing we'll encounter is how harsh and nasty the space environment really is. We'll then explore what it really takes to get into space, stay there, and eventually go someplace interesting. Along the way, we'll apply an understanding of the laws of motion to see how orbits work and see what orbit types we use and why. Finally, in this block, we'll look at the launch problem and what it takes to get from Earth into orbit. In block 3, we turn our attention to the systems that do the job in space. We'll start by looking at observation payloads and the challenges of imaging Earth from orbit. Each spacecraft subsystem needed to support payloads are then explored, starting with electrical power and ending up with an in-depth look at rocket science. Last but not least, we'll apply our understanding of space systems and rockets, especially to understanding what goes into the huge launch vehicles needed to hurl us into space. All of this should keep us plenty busy throughout the course. The primary reference we'll use throughout the course is the textbook Understanding Space: An Introduction to Astronautics. While the course doesn't try to follow the book exactly, it does use many important figures and diagrams and follows the general approach to explaining key topics. For most lessons in the course, specific chapters or sections from the book will be referenced, and we recommend you read or at least review this material either before or after the video lecture to help you gain a better understanding of the topics. In addition to understanding space, the course also pulls from other popular books in the space technology series. These are listed here, as well as from inputs from over 20,000 space professionals who've taken this course and other TSTI courses over the past 15 years. Learning any topic online is a challenge. Learning about a complex topic like astronautics is even more challenging. For many people taking this course, learning online is a completely new experience. But don't feel bad. If you think about it, humans have been learning face-to-face for thousands of years, so we know what to expect when we walk into a classroom. Online courses have only been around for a few years. The diagram shown here should help you navigate the 4 core modules that form the basis for this online course, so you know what to expect moving forward. For simplicity, these 4 modules are called Learn, Explore, Do, and Show. You'll spend a good bit of your time in the Learn module, so let's start there. Learn modules provide the core instruction in each block and are composed of about 20-minute video lectures along with recommended reading. Following each lesson video, you'll be presented a set of progress check questions to help you gauge your basic understanding of the material. You can retake progress check questions as many times as you want. Accompanying each block, there is a study guide, which you can download and fill out as you go along to aid in your own study. The second type of module is called Explore. These modules add depth and context to the basic material in the Learn lessons. You are encouraged to view all of them at your own pace and in no particular order. Each one allows for different levels of exploration based on your own interest and previous knowledge. The third type of module is called Do. Do provides you the opportunity to practice what you've learned by undertaking the design of a real space mission. We expect you to attempt to solve all of the Do modules. However, if you're having problems or have questions with these or any part of the course, there will be forums, frequently asked questions, and other resources to allow you to interact with your seminar team and your course coaches. Finally, at the end of each block, you'll have the opportunity to show you know with a short quiz. A minimum score of 70% is considered passing on each quiz. If you are unable to reach a 70% level in the first attempt, additional review of the material is recommended before attempting to retake the quiz. Like in any course you've taken, we need a bit of preparation before we launch into learning. Here's what you need to do. First, read the course policy letter from the SMC Chief Engineer. Next, take the pre-quiz. The purpose of this pre-quiz is to assess your incoming level of knowledge and understanding of the course material. There's nothing to study, just jump right into it. Your score won't count against you. It is simply a tool to help us gauge the effectiveness of the course. You will get to take it again at the end of the course, and we'll be able to measure your overall progress. After the pre-quiz, you're ready to start exploring the course. Start by reviewing the course handbook so you're familiar with the mechanics of using and navigating this learning management system. This is a good reference you can return to anytime during the course and has links to frequently asked questions and other resources. With the preparation complete, it's time to start learning. Go to the first block, Using Space, and dive right in. Where should you start? Well, that's pretty much up to you. We've created a self-directed learning environment that lets you decide how best to move through the material. For example, you may want to start by going through all of the lessons in the Learn module one by one. Then browse the Explore modules before rolling up your sleeve and tackling the Do activities. Or, if you prefer, you can go through 1 or 2 lessons, browse a few Explore topics, then try to do the first Do activities. It's entirely up to you. Strictly speaking, each lesson builds on the ones before it, so it's a good idea to go through them in order, but again, that's not necessarily required. But you must complete all the lessons before attempting the end-of-block quiz, but that's about the only restrictions. As you climb your learning trajectory, keep in mind you're not alone. If you have any questions as you go along, post them on the block forum. There, one of your instructors will answer you as quickly as possible, and your fellow students can see or comment as well. The most important thing to keep in mind is to have fun. Space is cool. Our goal is to make this course fun, engaging, and useful for you in your jobs and in your careers. If you have any ideas or suggestions for improvement, please let us know. Well, that completes this short introduction to the course. Thank you for your time and attention, and we look forward to working with you on your journey of space learning.